Welcome to our video on using trigonometric ratios to find angles. Let's go ahead and get started with example 1. Find the measure of the indicated angle. Let's go ahead and take a look at our diagram. We're looking for the measure for this particular angle. Instead of question mark, let me go ahead and use some mathematical notation and let me call it theta. Okay? Now, based on that angle, let me circle this angle. I can start to label the parts. The side right across from it is what we refer to as the opposite leg. And remember that the side across from your right angle is what we refer to as the hypotenuse. Now, if we go back to your mnemonic device, SOHCAHTOA, we can find a trigonometric ratio that uses both opposite leg and hypotenuse, and that happens to be sine. So we can go ahead and write the following. We can say that sine of theta, okay, this theta, is equal to the opposite leg, which has a length of 40 units, divided by the length of the hypotenuse, 57. Now, our goal is to get theta by itself. So we need to undo the sine. And how do we do that? Well, we simply take sine inverse on both sides. Okay, so let me take sine inverse of sine of theta on the left hand side, and I have to do the same on the right hand side. So let me do the following: sine inverse of 40 57s. Now, on the left hand side, we have sine inverse of sine of theta. The sine inverse does the opposite to the sine, okay? Undoes the sine. So we can just say that we have theta here. And that is equal to your sine inverse of 40 57s. Now, how do we get a good approximation for this one? Well, since we have the inverse, we can just get an approximation using your scientific calculator, or we can just use that particular form from decimals. So let me go ahead and look for a function. I'm going to find sine inverse. Notice it's here. So I have sine inverse, in this case, 40 57s. And take a look. It's approximately 44.6, okay? So 44.6 approximately, your theta, it's about 44.6 degrees. Okay? Now let's go ahead and see a couple more examples. Find the measure of the indicated angle. Again, one more time, I'm going to find my angle here. Instead of question mark, I'm going to call it theta, just to have some mathematical notation. I'm going to label the parts. This side across from your 90-degree angle is what we refer to as the hypotenuse. Then this leg that it's used to form that angle is what we refer to as the adjacent leg. And if you remember, based on your mnemonic device, SOHCAHTOA, we can find the trigonometric ratios that will involve both hypotenuse and adjacent, and that happens to be, in this case, cosine. So I'm going to go ahead and write the following. Cosine of theta is equal to adjacent, which is 44 units in this case, divided by the length of the hypotenuse, which is 49. Now, how do we undo the cosine? Well, to get rid of the cosine and just get theta by itself, let's take the inverse. So I'm going to say cosine inverse of cosine of theta. Now, this is an equation, so whatever we do to one side, we must do to the other, is the same as cosine inverse of 44 49s. Now here, the cosine inverse and the cosine cancel each other, so you can just say theta is equal to cosine inverse of 44 49s, which is approximately Well, let's see. We want an approximation for this. We can go to Desmos. So let me go to Desmos. Oops, very quickly here. And I'm going to do my cosine inverse. So cosine inverse of, in this case, 44/49. Let me close my parentheses. And that's approximately 26.1 degrees. Okay. So we can go back to this one and say that's approximately 26.1 degrees. Okay. Again, if you are being asked for the exact value for theta, we can just say that theta is cosine inverse of 44/49. But usually you want an approximation. So we can say that it's approximately 26.1 degrees. So let's take a look at one last example here. Example 3. Find the measure of the indicated angle. Okay, so here's my angle. Again, one more time, I'm going to call this theta. Based on this one, I can label the parts. I have the opposite leg here. Then I have the adjacent leg as well. And I can find the trigonometric ratio that will use both adjacent and opposite legs. So based on the basic 3 trigonometric ratios, I know that this will be a case for tangent. Okay, so I'm going to write down tangent of theta is equal to the measure of the opposite leg, which is in this case is 17, over the measure of the adjacent leg, which is 34. Okay, notice you can say that this is tangent of theta equals 1/2. Okay, because they have the greatest common factor of 17. I can divide this one by 17 and this one by 17. Okay, and that will give, I will get 1/2. Now, how do we undo the tangent? Okay, well, just as we did in the previous examples, we will undo that one by taking the inverse of it. So let's go ahead and take tangent inverse of tangent of theta on both sides of the equation. Okay, so let me take tangent inverse on this side as well. Now I know for a fact that tangent inverse of tangent will be theta. Okay, so theta is equal to tangent inverse of 1/2. Now, as usual, in real life, we want approximation. So let's go ahead and find an approximation for tangent inverse of 1/2. To do that, you can use your scientific calculator, or we can use Desmos. Okay, so we're looking for tangent inverse of 1/2. Now, using Desmos, let me delete this one, and I can just say that I am looking for tangent inverse of 1/2. And take a look at that. My approximate value is about 26.6 degrees. Okay, so I can go back to my problem and say that the approximate measure of the angle is 26.6 degrees. So let's go ahead and write that down in there. And in a nutshell, we can say that we have both your approximate value for the angle, rounded to the nearest tenth, and we also have the exact value given to you by this expression. Okay, so keep in mind, as you're looking for the measures of angles, you probably want to do some inverse functions in there. So just pay attention in terms of what labels you need to create. Okay, thank you so much for watching. I wish you the best of luck in your homework. Bye-bye.